Conductometric titrations. Conductance is the ease with which the current flows through the conductor. Conductance is a reciprocal of resistance. The unit for conductance is ohm inverse, mho or Siemens. Any material which conducts electricity is known as conductor. There are two types of conductors, metallic conductors and electrolytic conductors. In the case of metallic conductors, metals conduct electricity. The metallic conductance is due to the flow of electrons. There is no transfer of matter during metallic conductance. With increase in temperature, metallic conductance decreases. In the case of electrolytic conductors, conductance is carried out by the electrolyte solutions. Electrolytic conductance is due to the mobility of ions present in electrolyte. There is a transfer of matter during electrolytic conductance. With increase in temperature, electrolytic conductance decreases. It is increasing, not decreasing, it is increasing. Applications of conductance measurements. There are many applications of conductance measurements. To mention a few, determination of degree of dissociation of weak acid, determination of ionic product of water, determination of solubility of sparingly soluble salt, conductometric titrations. Conductometric titrations are performed in the laboratory using conductivity meter. Even at UG level, various types of conductometric titrations are performed. Before starting the measurements, the instrument is calibrated with potassium chloride solution. Initially, for example, if we are going to titrate hydrochloric acid with sodium hydroxide, 40 ml of hydrochloric acid is taken in the beaker. Why we are taking 40 ml? The conductivity cell must be well immersed in the solution. Accordingly, the volume must be chosen. Sodium hydroxide solution is taken in the burette. In order to get the accurate results and a sharp endpoint, there should not be any significant increase in volume during the course of the titration. Hence, the burette solution must be 5 to 10 times stronger than the pipette solution. Now, initially, the conductance is measured for hydrochloric acid. Then, sodium hydroxide solution is added in 0.5 cc portions. After each addition, the solution is stirred nicely and the conductance is noted. After the experiment is over, conductance is plotted against volume of alkali added and the endpoint is noted from the point of intersection of two straight lines. Using the basic formula V1N1 is equal to V2N2, the strength of unknown solution can be calculated. What is the principle of conductometric titrations? The electrical conductivity depends upon the number and mobility of ions. What is mobility of ions? Speed of an ion moving under unit electric field. Electrolyte is taken in a beaker where both positive ions and negative ions are present. the cations move towards the cathode and the anions move towards the anode when electric current is passed through the solution. Titration of a strong acid versus strong base. Example, hydrochloric acid versus sodium hydroxide. As we have seen earlier, hydrochloric acid is taken in beaker and conductivity cell is immersed in it. Sodium hydroxide is taken in the burette. Initially, high value of conductance is observed. On adding sodium hydroxide, conductance decreases along the curve AB. Once the endpoint is reached at X, all hydrochloric acid has been neutralized by sodium hydroxide. After that, the increase in conductance is observed. Now, the initially high value of conductance is observed, that is due to the presence of fast moving H plus ions in hydrochloric acid. Then conductance is decreased. This decrease in conductance on adding sodium hydroxide is due to the replacement of fast moving H plus ions by slow moving Na plus ions. After the endpoint, increase in conductance is observed due to the presence of hydroxyl ions provided by sodium hydroxide solution. Next type, titration of a weak acid with strong base. Example, acetic acid versus sodium hydroxide. Acetic acid is taken in a beaker and sodium hydroxide is taken in a burette. Initially, low value of conductance is observed. Then on adding sodium hydroxide, slight increase in conductance is observed. After the endpoint, a sharp increase in conductance is noted. Now, the low value of conductance is due to the presence of feebly ionized acetic acid. A slight increase in conductance is due to the formation of a salt sodium acetate. After the endpoint, increase in conductance is due to the presence of hydroxyl ions in sodium hydroxide solution. Similarly, titration of strong acid versus weak base can also be performed. In this case, hydrochloric acid can be titrated with ammonium hydroxide, which is a weak base. In that case, initially high value of conductance is observed due to the presence of H plus ions in hydrochloric acid. On adding ammonium hydroxide, decrease in conductance will be observed. After the endpoint, slight increase or constancy in conductance is observed, or reverse of this graph, because ammonium hydroxide is feebly dissociated weak base. Next type, titration of a strong acid and a weak acid with strong base. Here, equal volumes of hydrochloric acid and acetic acid are taken as a mixture, and this mixture is titrated against sodium hydroxide. Combination of 3 curves are obtained and 2 endpoints are observed. Initially, high value of conductance is observed due to the fast moving H plus ions present in hydrochloric acid. On adding sodium hydroxide, decrease in conductance is observed due to the replacement of fast-moving H plus ions by slow-moving Na plus ions. After this first endpoint, slight increase in conductance is observed due to the formation of a salt sodium acetate. After the second endpoint, increase in conductance is observed due to the presence of hydroxyl ions in sodium hydroxide. Now, the first endpoint is due to the titration of strong acid versus strong base. Second endpoint is for the titration of weak acid versus strong base. Next type, precipitation titration. Let us take an example of titrating silver nitrate versus KCl. Now, initially, there is no change in conductance. This is because silver plus is replaced by K plus and both are having almost similar mobility. Since there is no variation in mobility of ions, there is no change in conductance also. After the endpoint, silver chloride is completely precipitated and this increase in conductance is due to the presence of K plus and nitrate ions present in the solution. Advantages of conductometric titrations. Using volumetric method, colored solutions cannot be titrated by adding indicators. In those cases, conductometric titrations can be employed. This method of titration can also be used for the titration of very dilute solutions and also for weak acid versus weak bases. No special care is necessary near the endpoint because here the endpoint is noted graphically. The results obtained in the case of conductometric titrations are more accurate compared to volumetric method. Thank you.